Imagine receiving a beam of light that began its journey before our solar system even existed. For billions of years, that tiny signal crossed an expanding universe until it finally reached a golden mirror floating nearly 1.5 million kilometers from Earth. That mirror belongs to the James Webb Space Telescope, and every observation it makes is more than a photograph. It is a glimpse into the universe's earliest memories. When Webb was launched, astronomers expected remarkable discoveries. They believed it would sharpen existing theories, measure distant galaxies more accurately, and fill in the missing details of cosmic history. But what happened instead was something few scientists anticipated. The deeper Webb looked into space, the stranger the early universe appeared. Because light takes time to travel, looking farther into space also means looking farther into the past. Some of the galaxies observed by Webb emitted their light more than 13 billion years ago, allowing scientists to study the universe when it was still incredibly young. For decades, astronomers believed the first galaxies would be small, dim, and chaotic. According to computer simulations, it should have taken billions of years for gravity to transform scattered clouds of gas into the large, organized galaxies we see today. But Webb's images told a different story. Instead of finding only tiny collections of newly formed stars, researchers discovered galaxies that appeared surprisingly bright and unexpectedly massive. Some were producing stars at astonishing rates, while others seemed far more developed than current models had predicted for such an early period of cosmic history. These observations immediately caught the attention of astronomers around the world. Did the first galaxies grow much faster than expected? Or had scientists underestimated how efficiently gravity could build structure in the young universe? Before reaching dramatic conclusions, researchers carefully checked every possibility. Measuring enormous cosmic distances is extremely difficult. The farther an object is, the more its light stretches as the universe expands. This phenomenon, known as redshift, allows astronomers to estimate how far away a galaxy is and how long ago its light began its journey. At first, some scientists wondered whether the distances had been overestimated. If that were true, the galaxies would actually be younger and closer than originally believed. However, as more observations were collected, many of the surprising results continued to hold up. While some distance estimates were refined, Webb repeatedly found galaxies that appeared to have formed only a few 100 million years after the Big Bang. That doesn't mean our understanding of cosmology is wrong. Instead, it suggests that the earliest generations of stars and galaxies may have formed far more efficiently than expected. One possible explanation is that enormous clouds of hydrogen collapsed rapidly under gravity, triggering intense bursts of star formation. In regions packed with dense gas, stars may have formed at extraordinary speeds, allowing galaxies to grow much faster than earlier computer models predicted. Astronomers are now updating simulations to test whether these conditions could naturally produce the objects Webb is seeing. Another fascinating clue comes from the brightness of these ancient galaxies. Brighter galaxies usually contain either huge numbers of stars or stars forming at an exceptionally fast rate. Webb has found evidence that some early galaxies experienced enormous star-forming events, producing thousands of new stars in relatively short periods of cosmic time. If confirmed, these observations suggest that the young universe was not a quiet place slowly building itself over billions of years. Instead, it may have been an energetic environment where gravity rapidly assembled matter into increasingly complex structures. Even so, scientists remain cautious. Every major discovery must survive repeated observations and independent analysis before becoming part of accepted scientific understanding. Webb's mission is still ongoing, and each new dataset helps researchers improve their understanding of what happened during the universe's first few 100 million years. Perhaps the most exciting aspect of these discoveries is not that they overturn decades of research, but that they reveal how much remains unknown. Science has always advanced by confronting unexpected evidence. Every time a new telescope opens a wider window into the cosmos, it uncovers mysteries that previous generations could never have imagined. The James Webb Space Telescope is continuing that tradition. Rather than providing all the answers, it is revealing a universe more dynamic, more complex, and more fascinating than anyone expected. And this is only the beginning. If the early galaxies observed by the James Webb Space Telescope challenged astronomers, the next discoveries made the universe seem even more mysterious. Every new observation has added another piece to the puzzle, showing that the cosmos evolved in ways scientists are still trying to understand. One of the biggest mysteries involves supermassive black holes. Today, nearly every large galaxy is believed to contain a giant black hole at its center. These cosmic objects can contain millions or even billions of times the mass of our Sun. According to current theories, black holes grow by pulling in gas, dust, and sometimes merging with other black holes, a process that usually takes an incredibly long time. But Webb has detected signs of enormous black holes that already existed when the universe was still very young. This discovery doesn't break the laws of physics, but it does raise important questions. How did these giants become so massive in such a short period? Were they born larger than expected? Did they feed on surrounding material at extraordinary rates? Or did conditions in the early universe allow black holes to grow much faster than today's models predict? Researchers are actively exploring each of these possibilities, but no single explanation has yet been confirmed. While black holes remain one mystery, Webb has also transformed another field of astronomy, the study of exoplanets. Before Webb, astronomers could identify many distant planets, but learning what their atmospheres were made of was far more difficult. Webb changed that by using an incredibly precise technique known as transmission spectroscopy. As a planet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere before reaching the telescope. Different gases absorb specific wavelengths of light, leaving behind unique chemical fingerprints. By analyzing those fingerprints, scientists have detected water vapor, carbon dioxide, methane, and other molecules in the atmospheres of several distant worlds. These discoveries do not prove that life exists beyond Earth. Instead, they reveal something equally exciting. Planets throughout our galaxy are far more diverse than astronomers once imagined. Some have giant atmospheres extending thousands of kilometers into space. Others appear to contain thick cloud layers, unusual weather systems, and temperatures unlike anything found in our own solar system. The more Webb observes, the more scientists realize that there is no single blueprint for how planets should form or evolve. Another fascinating discovery involves complex carbon-based molecules drifting through deep space. These molecules are not living organisms, nor are they evidence of alien civilizations. However, they demonstrate that the chemical ingredients needed for increasingly complex chemistry appeared surprisingly early in the universe's history. Long before Earth formed, the cosmos was already producing many of the building blocks that would later become part of stars, planets, and perhaps even environments capable of supporting life. Webb has also captured breathtaking views of regions hidden behind enormous clouds of cosmic dust. Visible light telescopes often cannot see through these dense clouds, but Webb's infrared instruments can penetrate them, revealing stellar nurseries where new stars are actively forming. For the first time, astronomers are watching these hidden regions with extraordinary clarity, helping them understand how stars are born, how planetary systems develop, and how galaxies continue evolving across billions of years. One of Webb's most powerful tools is also the universe itself. Sometimes massive galaxy clusters act like natural cosmic magnifying glasses through a phenomenon called gravitational lensing. Their immense gravity bends the path of light from even more distant galaxies, making objects that would normally be too faint appear bright enough for Webb to study. This remarkable effect allows astronomers to observe galaxies that would otherwise remain invisible, extending our view even farther into cosmic history. Perhaps the greatest lesson from the James Webb Space Telescope is not that it has rewritten everything we know. Instead, it has reminded us that science is always evolving. Every unexpected observation encourages scientists to refine theories, improve computer simulations, and ask better questions. The universe hasn't become stranger because of Webb. We are simply seeing it more clearly than ever before. As Webb continues its mission over the coming years, astronomers expect thousands of additional discoveries. Some will confirm existing ideas, while others may reveal entirely new mysteries that future generations of scientists will spend decades trying to solve. The history of the universe is still being written, one ancient photon at a time. And somewhere in the darkness, beyond the reach of today's imagination, countless discoveries are still waiting to be found. If you enjoyed this journey through the cosmos, don't forget to like this video, subscribe for more space documentaries, and share your thoughts below. What discovery do you think the James Webb Space Telescope will reveal next? Whatever the answer, humanity has only just begun exploring the deepest chapters of our universe.